All right, these are notes for graphing proportional relationships. The last notes we took on note 3 was to determine if a table was proportional. To determine if a table is proportional, we look for the constant of proportionality. Remember the constant of proportionality? You have to have this formula memorized. The formula is y divided by x. And so let's check to see if this table is proportional. Again, to do that, you do the y number divided by the x number. So 2 divided by 1 is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. So yes, this one is proportional. The table is proportional because all the numbers, all the ratios are equal, and that means the constant of proportionality is 2. Now let's graph it. Knowing that this is proportional, let's draw a picture of it and see what it looks like. To graph a point, remember, it's always the x value and then the y value. So the first number 1 tells us how far to go on the x-axis. The second number y tells us how far to go on the y-axis. I remember to graph a point, we run and then we jump. The first number tells us how far to run, left or right. The second number tells us how far to jump up or down. So the first one is run 1, jump 2. There's the first point. The next one is to run 3. 1, 2, 3, jump 6. 1, 2, 3, 4, 5, 6. The third point is to run 4, jump 8. There are our 3 points. If I then connect those, got my fancy ruler. Just kidding, I'm at home, so I forgot my ruler at school. This is our proportional graph. This I know is proportional because the table told me this relationship was proportional. Let's try another one. For this second one, we check to see if it's proportional again by doing the constant of proportionality's formula, y divided by x. So y divided by x, 2 divided by 0. If you type that in your calculator, it's going to say error, or you can't divide by 0. You're not allowed to divide by 0. 0 cannot be in the denominator. So we got an issue already. Then we would do 5 divided by 3. Let me get my calculator. 5 divided by 3 is 1.6 repeating. And then 8 divided by 4 is 2. If you look at these quotients, they're not the same, which means this relationship is not proportional. Let's graph it to see how it compares. Again, to graph a point, we're going to do x and then y. So the first point, 0, 2, over 0, up 2. The second one, over 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. And then over 4, up 8, 1, 2, 3, 4, 5, 6, 7, 8. There are my points. Now, if I try to connect them with a line, I can't get all 3 of them in a straight line. So this one is kind of a curve. This is a not proportional relationship. This graph is proportional. These two graphs look very different from one another. This line is a straight line, right? So to be proportional, it has to be straight. Also, this line goes through this special point. That point is called the origin. This graph does not go through the origin. We would see if we graphed more proportional relationships, we would see that the characteristics here of it being straight and going through the origin will always be the case. We would also see if we graphed more non-proportional relationships that the graph will not be both of those things. It can be straight or can go through the origin, but it won't be both. So just in summary, for a graph to be proportional, 2 things have to be true.